Okay, so we're up and rolling. Nice. All right. Hi, everyone. Welcome to our webinar on container security. My name is Rowan Ben-Nour. I'm the product manager here at Canonical for containers, and I'm joined with two of my favorite people here at Canonical. That may or may not be a truthful statement, but it's fine. Cristobal and Diogo. Cristobal, do you want to give us a little quick intro on yourself?
Yeah, sure. Well, so my name is, just Chris. The whole thing is a mouthful, so just call me Chris. I am the engineering manager for basically a team of container specialists at Canonical. We do everything from your beloved Ubuntu-based container to application container images, everything based on Ubuntu, but also the tooling that we use to build our containers, including Chisel, which is something that we'll talk about during this session. And yeah, I mean, my background before joining Canonical, I always worked in computing. I've worked with computing grids before, commercial clouds, integration of commercial clouds into computing grids, and then edge computing as well. So right from the very beginning, I was always working with virtualized environments, and I started shifting more towards containers recently in my last 5 or 7 years. So yeah, that's pretty much it. Diogo?
Nice.
All right. And I am Diogo. I am, as well as an engineering manager here at Canonical. I work in the area of security engineering, and my day-to-day is taking care of our expanded security maintenance offering that is bundled with Pro. So while my day-to-day is spent figuring out CVEs and how do we patch them, I have a background in working in container-heavy companies. Like one of my first things at the first company that I worked at was writing a container orchestration system just out of Bash. I can tell you it was a formative experience. And yeah, I do have some good insights on how to work with security and containers.
Amazing. Thank you guys so much for joining us today. And I'm very excited for the discussion that we have ahead of us. I'd also like to thank everyone that's tuning in and joining our webinar. We do have a very limited time today in terms of our discussions. So I would like to ask everyone to leave your questions in the comments if they do arise during our webinar, and we'll make sure to get to them at the end. So awesome. Diogo, why don't you start us off with telling us a little bit about what people really should consider when they think about containers?
Certainly. So, as I said, this is a presentation, this is a webinar about container security, and let me start right out of the gate by saying that there's ample content on this. So, as we will discuss a bit more later, container adoption has continued to be on the rise. I still remember when containers first came into the scene, and we have produced a lot of material for it. Like there's a lot of ample resources. However, there are sometimes small elements that are perhaps not as popular or forgotten when using containers in your day-to-day operations. So here are some things that occur to me as a security professional. When I'm reviewing somebody that comes to me and say with a proposal that says, oh, we want to start using containers for our applications and we want to put them somewhere running. Here are more or less the things that I look for. Next slide, please, Juan. So the first one is, let's talk about building your custom images. So registries at the moment offer a big combination of base images for popular applications. So you can get your hands on Nginx, you can get your hands on Apache, you can get your hands on Grafana, you can get your hands on pretty much a lot of the popular stacks that exist. And these come with multiple combinations, either full OS, minimal OS, distro OS, and so forth. And for the vast majority of cases, picking up one of these container images is going to be probably the right solution for you. It's not to say that this is not fraught with peril, in a sense. Like there are some challenges in using these images straight out of the registries, but we'll leave that a bit for later. Here I'm going to talk about the case where you have a very particular application that needs some non-standard interaction. let's say that your application needs to do heavy manipulation of PDFs to produce it. Let's say it's an invoicing application that needs to do so. Or your application needs to do image manipulation, right? These are packages, these are done generally through packages that are not found in these base configurations, so you might need to run a custom image. And the case for a custom image is, while you have the option of building them from scratch, which is exactly how the term is used, you can also build them upon a base image. So you pick your base image and you start layering all of your necessary contents until you get to the point where you need to be. For example, if you have an image, if you want to have an image that has PDF manipulation capabilities, you can start, but it has to serve a web application. You can start from an Nginx container that has sufficient heft, so it has the utils that you need, and you can layer on top of it the packages that allow you to do the PDF manipulation. So adding these layers is a simple process. There are a number of declarative languages that you can use to start from a base image and layer up. However, here is where the traps show up, because you can be a bit over-eager in what you put in your image. So images are constructed, as I said, through a sequence of layers, and whatever you put in your layer stays there forever. If you are, for example, copying your application straight into that layer, let's say that you have a /app within it, you have to be careful that you don't include anything that you wish to keep private. So let's say that you are building this in your home device. Hey, you have to pay attention that you don't include any of your tokens that allow you to access your CI/CD or any of the APIs in the cloud in that thing that you copy. Same thing if you are running the build process in your CI/CD. You have to be mindful that when you are running commands to copy some contents into your image, you don't end up copying any sensitive tokens into it, right? And these are things that are sometimes not checked because people, as they put their image on build, as soon as the sign hits green at the end, oh, let's publish this immediately. And my advice is that you don't. Actually, run some tools over the image that you just produced and run some checks to ensure that you didn't copy anything that you shouldn't. And let's think, what's the worst that can happen? Well, please. Next slide, please. Right. What's the worst that can happen? Well, here is a piece of recent news. We've just this is from a few days ago in early February, where some researchers found out that a popular application that was distributed via Docker containers had included in it the npm RC, and thus the npm token, that allowed people to publish packages into the npm repo in their name. So in essence, anybody that could have picked up this container and dug through the layers or in the file system would have been able to then fully take over their package and distribute whatever contents they desired. Luckily, in this case, this was discovered by popular security researchers that then disclosed it responsibly. But if it had fallen into the wrong hands, you could have had yet another compromise within the NPM space and a continuous threat to supply chain security. Next slide, please. All right. So let's talk now about where do we put our containers running. Serverless is a very popular word right now. Right? People just say, oh, I don't need to worry about maintaining my servers. I'm just going to put it in a serverless offering, and somebody else has to think about that. There is no server there. It is serverless. And we know that's not the case. Serverless is a commercial word in a sense, because somewhere along that chain, there has to be a server that is running that computation. And containers are symbiotic in a way. So containers are simply a group of, a collection of permissions. And so C groups, namespaces, and so forth, that are then layered onto a system and make use of the capabilities of that system wherever they don't have it. So in essence, they depend on a lot of components from the host. So it doesn't matter if you have the most hardened container possible. If you are running these on an insecure host, you might run into issues. Let's say that you are running them on a host where there's, for example, a kernel issue that hasn't been addressed. And you are indirectly or directly exposing something that relies on that kernel functionality in your container. That simply puts that vulnerability into the attack surface. So it's not just a case of what is exactly on the container, but also the host that supports it has to be it has to be secure, so that all the links in the layer, in the chain, are have the right level of security for your applications. So the lesson for this is basically, do take into consideration where you are running your containers, because those servers also have to be properly secured. Next slide, please. Right. So we have talked about the hosts. We have talked about images, and now we are at the stage where, let's say, you have decided to go with an image out of the registry. You have decided to use a serverless platform of some sort where you have a contract in place that guarantees that everything is going to be patched. Let's look at another possible pitfall here. So, safe defaults audit, which is a play on the common phrase of common sense isn't. So, those application of images that we discussed at the start, they are geared towards pulling them down from a registry and starting to use them immediately. For a second, in the example of Nginx, Nginx serves HTTP content out of the box. MariaDB, when you pull the MariaDB container, it gets a database going. And they do essentially what is expected of them, right? So in your setup, let's say that you have an application, you use an Nginx container for it, you use a MariaDB container for your application, you might just, all right, I'm going to pull them straight from the registry container and I'm going to run them directly on this service, and I will not think more about it. However, before deploying, and again, you should run a verification to ensure that the default configurations are sound for your circumstances and exposure. The image that we have here is a bit of a tongue-in-cheek reference to this, which is SolarWinds. SolarWinds was a platform that was compromised because it had a default password that was exceedingly trivial to guess, resulting in, I'm of course overly simplifying the case, but it resulted in making it very easy to exploit. In some cases, the containers make certain assumptions. The container images make certain assumptions about the environments where they're going to be running. So, for example, a MariaDB container may make an assumption that, or any other database, that I'm going to be reached only through the internal network where the hosts are vetted. So I may run out of the box without a password, because the only hosts that will be able to contact me will be hosts that are trusted. This is not always true. You might end up in a situation where where your database is exposed to the entire internet, either through misconfiguration or through your needs. Let's say that you do need to have a database somewhere that is receiving requests from outside for processing. In those cases, you may be inadvertently exposing you because, the database is actually started without any password. Right? So I've already said the case of MariaDB, where, for example, if you start a container, it may start without a password, then you, because it intends that it's going to be contacted by only an internal host. But let me give you another particular example. Next slide, please. So this is something that you get out of Grafana and a number of other applications. It's data that is exposed in what is a metrics endpoint, which details a number of metrics on how the server and how the service is running. And if you pull Grafana and you run it out of the box, this slash metrics endpoint is going to be exposed to whatever your configuration is. So if you have Grafana listening exposed to the internet, somebody can navigate to it, go to the slash metrics endpoint, and get access to this information. Well, why is this an issue? Oh, this is just some diagnostics data. It's not too relevant. Okay, but the case is you might not know it's there. Right? You are not looped in that this endpoint is exposed. And this endpoint can end up reflecting a number of things that you have running on your service, because it's all diagnostic metrics. So it can leak details about, let's say, due to a proper configuration, how many rows are in your database? What is your database name? What is the load in each individual database? So it is better to know that this information is there than to not know and have it open out to the world. And you can run into this issue if you simply pull. You can do it right now. You can run to your terminal, type in whatever your container runtime environment you prefer, and pull out your file, and you see that in your local host, you're going to have that metrics input there. And let's now look at where we are. So we have already decided on our host. We have already decided on our image. We have looked at the defaults, and we know, all right, we're not exposing anything that we do not know. That person over there in the picture, for those that are not in the know, is Steve McQueen in The Great Escape. And it's thematic that we're looking at The Great Escape here, because that is one of the, at least in my opinion, one of the most interesting threats that exist now to container usage, which is the aforementioned container escapes. So what are containers popular for? Containers, as they are lightweight and consume far less resources than a VM, are used generally by things like platform as a service, software as a service, as a way to produce, to gain density. So let's say that you go to one of the popular platform as a service offerings, and you decide to host your application. In all likelihood, your application is going to be hosted in a server that is running 200, 300, 400 containers, because those kinds of workloads can be supported through containers without big performance issues, and allows those platforms to leverage that density for lower costs and more efficiency. Now, I did say containers are more lightweight than VMs, but that also means that the isolation layer between them is a bit thinner. Not too much, because the mechanisms that create the isolation in containers are all sound, but it's a different thing where you have a number of containers all sharing certain functionalities from the host versus you running 5 fully hardware emulated VMs, obviously. So when we are running in particular environments where we have multi-tenant configurations, so we have multiple different customers running multiple different containers, it creates a juicier target, in a sense, where if you are able to escape into the host, you can extract a lot of aggregated information there. These are generally, these kinds of threats are going to be present if you run, for example, a service that gives people access to the container itself. Because it might be necessary. You might need access to the container for debugging. You might need access to the container to allocate space or manage your mounts. So there is a use case where, well, yeah, users should have access to the environment within the container. When we get to that, all the usual hardening precautions should be taken. So they should have a non-privileged user provision for them. They should have the capabilities of the container should be restricted, because there is no need for somebody inside the container to be able to allocate a new network or mount arbitrary devices, right? So as long as those measures should always be taken in those cases. But even then, a container escape might occur. These are quite sophisticated attacks. They are quite rare. They're very valuable. And they are sometimes ignored as part of regular threat models. Like people, when they say, oh, we're going to put this thing on containers, and then they just trust blindly that nobody's going to escape from the container, so everything will be okay. We know this not to be the case from experience. And here's an example. So The image that I chose there is a very peculiar image. Let me give you the context. So that is, this is straight out of Wikipedia. That's an example of the Gros Michel banana. This banana was the banana that we ate in the, I believe, 1960s before the Cavendish became the most popular banana. And why am I giving this example? Well, because bananas are a very particular plant. Like containers, bananas are clones. They're identical. Containers are identical by design. Bananas are identical by design. And what happened with the Gros Michel and why we stopped eating it was that the banana, that species of banana, was not resistant to an invading fungus that was basically wiping out its whole population. We then switched to the Cavendish because we simply could not develop this banana fast enough to resist it. And the parallel that I want to draw here for containers is that containers are all identical by design. Once you have a base image, whatever containers you spin out of that base image are going to be identical. And this creates an issue. So if you have a container image, be it a container image that you created or a container image that you plucked out of a registry, if there's something in that image that is under active exploitation, following the usual playbook of isolating or destroying those containers and spinning up new ones is not going to get you ahead. It's going to offer the same pathway to compromise. Like if I have a trivial exploit for a particular container configuration, you can spin up containers as fast as I can take them over. So it's not a way to battle that kind of active direct compromise. The suggestion here, and this is something that most users do not do, is that, in my perspective, you should have a warm fallback option that supports the basic services that you need to prevent excessive downtime. Let's consider a specific case. You're running a web application. You're running Nginx. You're running a database server of some sort, and you're running Redis, and it's something else to provide cache. If you have an issue that, let's say, affects Redis, until you can deploy a fresh container image that contains the fixed version of Redis to take over across your whole estate, it's going to take some time. It's also going to take a big bandwidth cost to push that image out aggressively into every single server that you have because you have to get ahead of the vulnerability. If you account for the situation and you create a separate image, a separate low-weight image that you keep around, that you can switch very quickly, like something that only has the very minimal services and responds to no requests. It's simply there saying, hey, we are experiencing technical difficulties. Please try again in 5 minutes. You can gain some time for you to then progressively push out the fixed image while still maintaining uptime. In essence, you don't have to cut down your entire population of containers to then replace them whole. You can stagger that if you have a separate image that uses a separate service or a separate implementation that hopefully is not affected by the original exploit that you're running through. And these are the 5 things that I had. As I said, these are colored a lot from my experience working at a company where containers were used for a lot of these functionalities. And I hope that you have thought about something new that you can consider in your future security program.
Thank you so much, Diogo. We've actually seen that, in despite of all of these things that someone should consider when looking at containers, we've seen that they're actually still skyrocketing in adoption. Especially the past couple of years, we've seen that containers has been a very hot topic. Chris, I'm intrigued if you think that this is something that will continue to grow, or what is your outlook on it?
Yeah, I mean, definitely. There's, in fact, this report from Gartner that kind of estimates that in a few years, most global organizations will be running some sort of application containers, and a significant number of their whole application stack will be run inside a container. And I think there are many reasons for this. First, containers have been popular for more than 10 years now. There are tools in the ecosystem that allows us to build containers very easily. And what Diogo was saying, it is true, but I feel it is more like a more recent awareness movement. People are becoming more aware of what else needs to be improved, because if something is really easy to do, there might be something else to it that we should look into. And security is obviously one of these problems. Now, how do people actually do containers? And because it's easy, if you go to the next slide, the point here is, yes, it's easy to build a container. There are tools for it. And the kind of the standard practice, at least at the very beginning, was that you just choose a base image, right? You go there, you choose one of your favorite distro-based container images, Ubuntu or any other, and you, from the get-go, you have just a base of stuff that you can use in your build process. So that's great. Okay. Then you add your application. Your application has dependencies. So you start adding more stuff, right? You apt install something, and maybe you add some recommendations by default as well, because it may be useful. And at the end, you basically end up with a very chunky container, a very big thing that works. So as long as it works, it's okay for you, and you just go with it. The problem is that, and this is where this kind of self-awareness starts becoming a big trend nowadays, is that with chunkier containers, we see higher network costs, of course, because you have to pull those containers from a registry. And if you are employing continuous deployment, you'll do that many, many times. With a bigger container, there's also a very strong correlation with the wider attack surface, because you will end up having stuff in that container that you don't need. It's just there because it was easier to keep it there during your build process. And since it's there, CVEs might pop up that you didn't know about, or CVEs will be there from the get-go that you didn't care about. And finally, the bigger it is, your container, the harder it will also be to get compliance with certain regulatory standards. Like if you want to harden your container, it will be much harder because you have so much stuff to kind of try to patch to get compliance that it's just really hard to do it. So these are some challenges that once these companies started adopting containers at scale, they realized that the problem is not so much in the building of containers, right? But again, building is easy to some extent, but then the outcome of an easy build ends up creating a struggle in maintenance. It's hard to maintain a chunky container that has a lot of vulnerabilities. It is large and inefficient and insecure to have that many containers sharing similar pieces of the underlying system. So the base is the same, which is fine if you are reusing the same layers, but then you start kind of deviating on the subsequent layers a little bit at a time, and you end up with a lot of overlap, but layers that are not unique. So it's just inefficient at scale. It becomes complex. A lot of our build recipes today are based on imperative tooling. So you actually have to script something to end up with a container image. And the more complex your application is, the more complex your build recipe will be, of course, and this is hard to manage. And as I said before, it's, again, standards. I think nowadays this is becoming very popular that depending what you are, what your infrastructure is, you need to abide by certain standards. And again, the larger your container is, the more insecure it is, the harder for it will be to get that compliance. So yes, it is easy to build a container, but if you want to do it properly and address all the issues that Diogo mentioned before, this is a very hard craft to master.
We actually ran a poll recently to gauge like people's real world experience on what their pain points were when it came to container management, or more broadly, the container space. What did you think about the responses here? Are they kind of with what you would expect to see?
Yeah, I would say predictable. I think we had a significant number of people answering there. Of course, vulnerability management came up to be the first one. This is not the first time we do something like this. I think a few years ago, some of our colleagues ran a similar survey, and at the top of the answers were, again, vulnerability management and also transparency and control, which is the case of the second part, or lack of visibility. So that's not surprising to me. I think the two other most popular answers we got in this survey were image size. So this is kind of correlated with vulnerabilities, right? Because again, the smaller your image, the more likely it is to be more secure. and compliance again. So those are the topics we have been discussing since the beginning of this call. It's security, it's transparency, image size, and compliance with standards. So yeah, those kind of expected, and it's good to see that people are indeed becoming more aware that those are challenges, but they need to be addressed, right? So we need to do something about those. And I think one of the most popular movements that have been taking place recently is that in order to secure images, people are looking a bit more left in the supply chain. So security is shifting left in the sense that instead of waiting for images to be there and then worry about security, people are going to worry about security very early in the build pipeline of those images, sometimes even before those containers are actually built. Because again, containers are just a package of multiple different software components within. So in the end, the CVEs will come from those packages that you are installing inside a container. In most cases, of course, as Diego said, you can have other cases, especially when you talk about deployment and runtimes. But if you just look at the container image itself, if you start shifting left and securing early in your supply chain, you are going to look at the packages that you are installing inside your container, how secure they are, and how you can secure them. And you're also going to look at provenance, right? This becomes a pivotal step of your supply chain, which is I have to choose some sort of build environment for my container. And I say build environment on purpose because we will, on the next slide, start talking about distroless. And distroless does not mean to go without a distro, right? Which is something that many people think, but it is not. Like distroless is just a practice of reducing everything you don't need from a distro, but you still rely on a distro. So provenance is really important because in most cases, it is not impossible to do something which is a bit distro agnostic, but in most cases, you will have a piece of the distro in your container, even if you go distroless. The point here of this practice, which was kind of coined by Google a few years back, is that in order to secure a container, you may try to make it smaller. And to make it smaller, what you want to do, like the obvious step, is to reduce the container to the absolute essential. So remove everything from that container that you don't need. And the distroless term kind of comes from the fact that, oh, the obvious stuff I want to remove is to remove all the distro bits that come from my base that I know I don't need at runtime for my application to run. So conceptually, this is awesome. And this is a practice that we want to retain. Now, what's the caveat here, right? What's the catch? Containers, easy to build, quick to learn. However, if you want to go and start doing things a bit more properly and start following this distroless trend, this is actually hard to master nowadays. The further away you get from the distro, the harder it is to actually build containers that are maintainable, easy to update, that you can harden and audit, and that you can attest for provenance. More often than not, with the tooling that we have today, you might need some specialized tooling that can be complex. You might need some very deep distro knowledge to make it distroless, which is like, I know it's a bit counterintuitive, but if you think about it, in order for you to know what to get out of the distro to make it distroless, you actually need to know a bit about the distro itself to know what you are doing there. And it can be error prone. One of the most popular approaches towards distro today is to build your container images in stages. So you kind of build everything up and then cherry pick down. So it's a top-down approach. And in this cherry picking process, you might end up either including something you shouldn't or leave out something you shouldn't leave out. So it can be very error prone and it gives room for interpretation. And then you are not using package managers that do some of the heavy lifting for you when it comes to, for example, using third-party tools against your container images like scanners. So there's a study here on the next slide that kind of depicts exactly this problem. It isn't meant to be looked at as distroless images only. In fact, the study here took 20 of the most popular images in the popular registry. Those images remain unnamed, but they also scanned 6 different vulnerability scanners. And the point of this study here was to test the reliability of scanners for container images. What they saw was that all of the 6 scanners, scanning those 20 different images, they reported something different, all of them, no matter what. Aggregated, more than 450 vulnerabilities, high and critical ones, were misidentified. And the thing that actually concerns me the most, and the thing that I'll be focusing on for the remaining of this presentation, is that at least one of those tools reported more than 16 false negatives. And false negative is a blind spot. This is really dangerous. So why is there so much unreliability when it comes to scanning container images? There are many causes. Actually, some of them Diogo covered before. But if we put those aside, like configuration of the application and the ecosystem of the software that you have inside your container and what the scanners can look at and they can support, one of the most obvious reasons to why certain scanners kind of report false negatives, which they don't report, like they fail to report CVEs, is because they are unable to detect software components. Right? You give them a container image, and because that container image was, for example, not built with the aid of a package manager, there is insufficient metadata inside that container for the scanner to know what's inside. I know it's a bit counterintuitive that scanners rely on the information that you give them in order to tell you how secure your container is, but that's how it works. In most cases, at least, and for certain ecosystems. So I don't want to generalize this concept, but at least here, since we are talking, in this case, let's talk about Debian packages. I'll give you the example where most scanners are going to rely on the package status metadata to tell you what software packages, what Debian packages have been installed. So if you don't have that simple file there, and you can run that test by yourself at home, take any image, an Ubuntu-based, Debian-based image, and just remove the package status file, run a scanner through it, and it will kind of tell you that, in most cases, it will tell you that you have 0 CVEs. So this is a false negative. This is a blind spot. So this is why we came up with Chisel. So look at the distroless way, which is typically top-down. We are trying to rethink how to build distroless containers, go one step beyond distroless. And this is to take a managed bottom-up. And these two words are key here. It's managed and it's bottom-up. We built from the ground up, not from the top down. So we kind of lose that error-prone process of doing things because we start from scratch and we build up, not the opposite. And it's managed because we are using a tool that behaves very similar to a package manager. So for us, this is the right modernization approach because Chisel is a Canonical-driven tool from the same people that develop Ubuntu, and it only handles Ubuntu packages. What it means is that you can build a distroless-like container image that is based on Ubuntu packages without any alteration whatsoever of the software itself. It's the same data that you would have on another full-blown container image. It's just chiseled. And I'll tell you what chiseled is in the next slide here with this illustration that kind of tries to depict on the left side how Debian packages are in a distro versus how Chisel sees them. So on the left side, you have your typical relationship between Debian packages. You have package A, B, and C. And those can have dependencies between them. So when you install one, you'll get the other one, which will get the other one. So all of this is handled by your package managers like apt. On the right side, what Chisel does is that, hey, actually, especially for a container, even though Chisel is not a container-specific tool, it just generates a file system. But especially for containers, I know that I need to run application full. And that application literally only needs this, and that, right? Some of my dependencies, they come from certain Debian packages, but I don't need the entire package for my application to run. So with Chisel, what we do is that we create slices of packages. We go to each one of those dependencies and we decide, okay, let's create logical groupings within this package. And we call them slices. So we are basically splitting that package into a declarative definition of what a slice is with contents. And slices can also have dependencies amongst them, very much like Debian packages. So Chisel will only operate on slices, meaning that it will create a Chisel Ubuntu file system, a slice of Ubuntu, that is still functional for your application, but it only has portions of the Debian packages that you would find on a full-blown Ubuntu-based container image. So it's a chiseled Ubuntu image. So that's basically the message here, is that while apt installs Debian packages, Chisel installs Debian package slices. Now, what is a slice? What does a slice look like? Because that's kind of the fundamental piece that Chisel relies on in order to be able to build these file systems. Well, a slice is basically a YAML block, is a YAML snippet. That's it. We could stop here, but the thing is, we can have as many slices as we want. We can have virtually an infinite amount of slice definitions. And the way we have organized this is that for each package in the Ubuntu archives, we will have a YAML file. So in this case, I'm doing the example for the very essential package-based password, which as a Debian package, it has 17 files, 2 dependencies, and approximately 250 kilobytes of installed size once you install it. However, and for these, it's a silly use case. It's a functional one nonetheless. We do this in some of our containers. But if you consider that, hey, I just want to have the ability to have users and groups in my system, I don't need anything else, right? So how do I get this ability? Well, there is a package called base password that provides this and more. I don't need more. I just need that though. So I'll create a slice. We call it data. In this case, names are custom. I could have created something else, and I could have created as many as I wanted, but I created a slice called data that only has, in this case, I have 4 contents, but 2 of them are mutable, meaning that they are going to change. This is a feature of Chisel. It's a bit too deep here. It doesn't really matter, but I can actually try to do the same thing. I can reproduce a Debian maintainer script in Chisel through a mutation script. In the end, the result of this slice installation here will be 2 files, the etc group and etc password. And those will give me the functionality that I need for user and group management. And I end up with an installation that is functional for what I need it to be in my container, which is 2 files and 4 kilobytes of size instead of the 17 files and 250 kilobytes of size of the whole deb. So that's going one step beyond distros. Why? Because we are preserving the distro. It's still Ubuntu. We are not altering, we are not tampering with any of the software to make it smaller. We are not recompiling to make it even smaller. Like, we are not doing any of that. It's the same packages. If you are using Ubuntu in your server, in your desktop, in the cloud, whatever, and you are shifting your application to a container, rest assured, because the packages that you are running in the server, in the desktop, in the cloud, are the same package that are going to get chiseled into your container. So it's all the same software, just delivered differently and kind of optimized in the sense of contents to be just enough to run your application. We just get rid of the packaged contents that are not necessary. And on top of that, to address the problem of blind spots, we also generate the Chisel manifest, which allows us to do record keeping and to have file level integrity. And I have a demo later on, but just a sneak peek at the Chisel manifest here. This is a file that we call a JSON log. It's basically a compressed document that sits inside our Chisel file system, where every line is a JSON object. That's all. And what it says is that it will tell you everything that has been installed in your Chisel file system, all the way from a package to a path level. So you'll have every path and its digest, its size, to the slice it came from, and the package it came from. So you can also have file level integrity. You will be able to resolve provenance, and it's all in a machine readable format. So you can parse these with tools like JQ, for example. And this is compressed in your file system, so it will not take much size, and it's also custom, so you can install it whatever you want. It's actually delivered by a slice. So we'll see that in a demo now. For now, it's just we have a recording here that we can talk about. I don't know before that, Howand or Diogo, if you wanna make any remarks or ask anything before we go to the demo. This demo here, the CV you see on the screen, was actually brought to me by Diogo. It was actually a good finding from Diogo. So if there's not, do you have any comments so far? No. So yeah, I'll just maybe say here what the CV is about. So Diogo brought this to my attention, and it's just for the sake of the example, a CV that comes from the package PCRE2. So I think you can run the demo, Howand.
Is that playing?
Yeah, you will need to change the settings because the quality is okay. Now it's good. Right, so yeah, this is the first part that I've explained already. So PCRE2, and this vulnerability is affecting Jamie. So let's do a very quick demo to show how it does affect Jamie. So I have an image here that I built from Jamie already, and I'm diving through it just to show you that I do have PCRE2 installed inside. So you can see there, filtered on the right side. And I have both binaries, including the one that causes the CVE. Now, I'm just going to do a smoke test here to actually make sure that the functionality is there, because I'm later on do the same counterpart test on a chiseled version of this Docker image, just to prove that the functionality is retained. So very simple here. What I want to achieve, let's assume that my application was PCRE2 grep. That's what I want, and I would get that output successfully. And by scanning this image, which has the full Ubuntu Jammy inside, you'll get a lot of CVEs, including the one that we just saw, right? It's a low CVE, it is there, and it actually states that it is due to the fact that we have the PCRE2 test inside, because it's delivered as part of that Debian package, right? So what if we slice the package, right? And to do that, we create a slice definition. So here we go to the package PCRE2 utils that delivers that file, and I'll create a slice, PCRE2 grep. Again, I could name it anything I want. I just put that I want the contents to be PCRE2 grep, not test, and I'll still declare all my dependencies, right? But I just leave out the PCRE2 test binary. And now I will cut that package into a brand new Ubuntu file system, or a chiseled Ubuntu file system, that I'll call rootfs here. And I'm going to say, okay, I want the package PCRE2 utils underscore, that's our notation. Anything that follows underscore is a slice name. And I said that I want the PCRE2 grep slice, nothing else from that package. And I also put some release information, and the base files chisel, that's the manifest that we talked about in the previous slide. You can see the last line there, generating the manifest. We'll go through it later on. But this is basically our tree. We only have 27 directories, a few files there, mostly libraries, and our binary, the PCRE2 grep binary. Okay, so what now? I pack this into another container image. I dive into it, and now you can see, first, it's much smaller from the get-go. I'll show you the difference in size in a second. But in terms of binaries, I only have PCRE2 grep there. I don't have the PCRE2 test. Difference in size, well, one is 14 megabytes, the chiseled one. The other one is 80 megabytes, which is the Ubuntu plus PCRE2 utils package. And if I run the same smoke test, again, I know it's very simple, it's a CLE test, but if this was my application, I want to make sure it's still functional. So running the same smoke test against the same OS release information, I get the same results. And this is where things get tricky. Now, if I 3D scan it, I'll get a false positive. Why? This is the problem that we were saying before. This is one of the problems that study found. Like, most scanners will associate CVEs with a package. But in this case, I clearly don't have that binary. I don't have that file, right? The whole image is still much more secure. Again, the correlation between higher content in an image and more vulnerabilities versus smaller image, smaller attack surface. But that CVE was not there anymore. So at least it gives you the possibility of justifying and saying, hey, by the way, the CV has been raised, but I actually don't have it. So now we could run another demo here instead. And this one is targeting one of the images that we have in Docker Hub. Let's take a more concrete application, Nginx, for example. And you can see there on the right side, I have multiple Nginx images already in my file system. So I have the Ubuntu ones, the upstream ones, Nginx, all 1.24. So you can see the size comparison between Alpine, Chisel, non-Chisel, and Debian-based, I believe. On the left side, top screen, I'm just going to run for the sake of, again, doing a smoke test, the standard Ubuntu Nginx image that has Ubuntu inside, and this is your default welcome page. All good so far. Okay, so I'm running that on port. I'm doing a port mapping to my localhost 8080. On the bottom, I'm going to show you something new. This is a rawcraft.yaml. Rawcraft is a tool that, apart from Chisel, it's yet another tool that we have. This one is for actually building containers, something that we call rocks. And it's declarative, not imperative. So everything here, you require little to no programming whatsoever. And you can clearly understand, I'm saying I want a bare base. It's like doing from scratch. But I still want my build environment to be 2404. Then we have services. Basically, it's our entry point. We use Pebble, which is like an init system on all of our containers. And what Pebble does is like a service orchestration. It's a zombie reaper, a log manager, all of that you'd expect from a service manager and init system. And I can say, hey, my service command is Nginx. And I want to run this container as a non-root user called _daemon_. And then I have parts. This is kind of the fundamental piece of Rawcraft. Every part is its own self-contained thingy that will get installed into your rock. It has its own life cycle. And here I'm saying, I want to install a couple of slices. I want to install the var www directory, set the permissions there, and I want to set some permissions as well for the path run. This is because I know I want this to be, I want those directories to be allowed to be readable and writable by my non-root user. On the second part that is separate from the first one, so this is one of the advantages of Rawcraft, I'm going to do something else. I'm going to install the actual Nginx software there. So I'm going to create a part that installs Nginx, installs, again, the Chisel manifest, so the release info, and it's going to, instead of the default welcome page, I'm going to put the Chisel manifest in our welcome page so we can actually look through it from the web page. And then I do Rawcraft pack. This is, again, our tool, and the pack command is basically building the whole thing. It's going to pull all of your software that you require for the rock, for your container image. It's going to build it, stage it, prime it, everything for every part, and compile everything into an OCI archive that you can see there called nginx something.rock. It's an OCI archive, which means I can ship it anywhere, including to my Docker daemon locally. So I copy it to my local Docker daemon so I can run it with Docker. And I'm going to run it there. This time I'm going to expose this second container on my localhost 9090 port. And this is called the Chisel one. So you can see Pebble is serving my Nginx service there. And the command is similar to the one we did before. This time, because I basically placed the Chisel manifest as my welcome page, you can see the contents of that JSON wall I mentioned before. So I have contents, I have all the packages, I have all the paths, I have all the slices that Chisel installed in my file system. And if you were to kind of create an SBOM out of this, which actually this is one of the purposes of this file, is that now you can generate other metadata and scanners can rely on this to know what's inside. If they were to rely on this, they would see, okay, I have only a few packages here from base files to zlib, whatever. Okay, that's all. And if you were to scan this, again, with Trivi, given the amount of packages that we have now in our Chisel image, you would find a huge reduction from 28 CVs to 2 plus 1 CV. There's one additional one there, which is for Pebble that we introduced there. This is a medium CV that might have been fixed already. But the point here is, again, because we have reduced our image size, we have also reduced our attack surface, right? but the functionality is there. All we did was get rid of the base, get rid of packages that we don't need. And from those packages that we do need, like Nginx, only bring the essentials to be able to do what we need to do. In our case, we just wanted to create a default index page, and that was all. So that kind of shows how you can go from a fully bloated image to a distro-like one, but go a step beyond, doing that in a managed way with Chisel, keeping your provenance and metadata contents such that scanners can also still later on be able to assess what you have inside and hopefully avoid those blind spots.
Perfect. Those are really great demos, actually. I really enjoyed those. Oh, no. Okay. We're having some technical difficulties. Well, we have a few minutes left, so I just wanted to run through something really quickly before I let everyone go, which is really talking about what Canonical does from an enterprise perspective in terms of everything that we've discussed, Diogo's discussion, Cristoval's discussion, and our container build service. So Canonical has the philosophy of everything LTS. So we would like to adopt everything open source that's out there under our Ubuntu Pro umbrella. And one way that we would provide that to customers is through the container build service. So Canonical will build, secure, and maintain our minimal optimized OCI containers on behalf of you to bypass all of the issues that we've, or not issues, but concerns, struggles that we've discussed during the webinar here today. And these containers can run on any CNCF conformant Kubernetes available, very environment agnostic. And we provide maintenance and vulnerability remediation on these containers done by Canonical Security Engineering. Diogo's here and representing that side of our company. And how the container build service really works is that you request the open source software that you would like. We will analyze, we build the container, we will test it, and then we provide it for you. So really everything that Diogo mentioned in terms of the concerns are taken away from you. Everything that Cristoval has mentioned in terms of building containers from a bottom-up perspective, in terms of maintenance and management of the packages inside, everything is done from a Canonical perspective so that you can deploy them readily in your environment. And that pretty much sums up everything that we've discussed today. We're a little bit over time, but I really want to thank you guys for joining us. I want to mention we also have a Rocks community on Matrix and Discourse, so please join us. We also host monthly meetings where we run demos, and we would love to get feedback from the community as well if you play around with the tools, and look on our GitHub as well if you would like to contribute to the open source community. We'd love to have you, and we'd also love to hear your feedback. So thank you everyone so much for joining our webinar. Thank you, Chris. Thank you, Diogo, for joining me today. I really appreciate it. And yeah, thank you everyone for watching.
Thank you. Well done.
Thank you, everyone.
Cheers.
Have a great day.